Hello to myself and everybody else. This is video 133. So far today, we're going to be covering the topic of polymorphism. And so far I'm talking about this topic based on the video from the 31-hour free code camp video. And so far I'm going to start off with just going over like two sites real quick to kind of cover some information on here. So far with polymorphism and everything and stuff here, this is the W3 School's website. So far, again, here it talks about polymorphism as basically just like related to inheritance. Basically saying like you have a parent class, then basically you have like a child class, and let's say all of them share the exact same method variable names. It's basically saying the compiler should be able to differentiate between those and know which one you want to use. So basically, here's like an example just showing there's a base class, a derived class, and another derived class. Both of them are children to the base class. And so right here's the whole code example and everything here, based on like the base class called animal. Base has a void function in it called animal sound. It just prints this out. The animal makes a sound. Then it has a child class called pig, and it's inheriting from the animal class. And so far again has the exact same method variable name or function name, where it's basically void animal sound, and then it says the pig, whatever sound it makes. Then the other class, the dog, also inheriting from animal, and same function, everything here too, saying the dog says and the noise it makes. It basically saying inside the main, you can make three objects, one from animal, pig, and dog, and then from here just say my animal, and then animal sound, my pig, animal sound, my dog, animal sound, and the compiler should be able to know which it's calling from. Basically, again, it's just looking at like the class and everything and stuff here and just saying, okay, so my pig is part of the pig class, so use the function inside of pig. Basic things like that and stuff too. I'll just like copy this and just run it from this and just run inside the other compiler I use, so we just like make sure it works. Hold on. So we're having a problem and stuff here. Okay, so I think I know what the problem is. I just don't have using namespace std. Now try it. And we also don't have the including IO stream, so let's try that. Okay, now we're going to try it. There we go. So basically, yeah, just showing that again, even though we have the exact same function in each one, it's going to look at the class and be like, okay, we know which one to use. So for the animal one, it's using the function from the animal class. From pig, right here, it's using the one from the pig class. And from dog, it's using one from the dog class. Base, that's the whole thing with polymorphism right here in the W3 schools one, base saying it's related to inheritance. Basically, it's really similar to that other video and stuff I did and everything too, based on the free code camp stuff, which basically again just talks about inheritance and everything and stuff as well. Basically, this is just that very simple example I was looking for but couldn't find because it was under a completely different name. So yeah, this is the whole thing and stuff with that. The other site and everything too is so far Geeks for Geeks. This one also talks about polymorphism. It talks about the same thing, but on the top, it talks about types of polymorphism, which is compile time polymorphism and runtime polymorphism. I'm not going to lie to you, I don't 100% get the difference with these 1000%, but basically it's just a matter of, again, the examples here, it just goes over. It just wanted to show that and everything. But yeah, basically, again, just saying like all of it basically is relating to inheritance and everything like that. Like with this one about like overloading a function and everything like that as well. Like, again, kind of a inheritance thing. Basically, like all of it stuff's here and all that and everything too, just showing like the different stuff for that. Again, the website Geeks for Geeks up here, and W3 schools, just look up polymorphism and then the site, and again, there it is. Or you can just like use the link and everything right there. And so far, again, down here, the runtime polymorphism is the same thing as the one from W3 schools, again, same with inheritance and all that. That's really the whole thing I wanted to show and stuff here. Because the reason I wanted to show this is because in the video and everything from the Free Code Camp YouTube channel, so far with that, when it talks about polymorphism, it does not really like use inheritance in this way. It mostly uses like pointers and references. It doesn't really use anything like basic like this. So yeah, basically just showing like if you look this up, you're just gonna find basic things on polymorphism and everything too here from these two sites, and from the video, everything else will be multiple files and kind of talking about references and pointers. So just wanted to bring that up and everything and stuff too. So again, just in case like when everything starts looking entirely different, we'll at least understand why. So that's the whole thing and stuff there. So far, the next thing and stuff like that is static binding with inheritance. And so far, this right here basically was like the first thing you kind of like started talking about polymorphism a little bit, but basically was just showing that you can basically it was just showing like a stepping stone of like what polymorphism can be and why you should use it, the way the video was using it. I'll go into that in a second. Basically, let me just show you the code and everything stuff real quick too. We're using a bunch of files again, so far this is the main CPP file and everything and stuff right here. I'll go ahead and scroll down so you can just see the rest of it. Then here's shape.h. Here's shape.cpp. Here's oval.h. Here's oval.cpp. And here's circle.h. And here's circle.cpp. Okay, so that's the whole thing there. So far with this and everything as well, basically what it was showing was that with this, we have again, shape, this is the parent class. Basically again, all it does is has two default constructors in it and a deconstructor. And base inside of it just has a void draw. And from here, it will just print out, you know, this right here, and then a description, which basic description is whatever we type in. The oval one does the exact same thing, except this one, it should be able to print out what the X and Y radius was that we typed in, as well as a description. And in the circle.h one, again, it should also basically be able to just use draw function as well. So if our oval used the same thing, oval also used draw. But a circle one, yeah, uses draw and basically prints out what it's drawing and then prints out the X radius, or it can be the Y radius, whichever one. It should be the same because it's a circle, but basically that's the whole thing and everything and stuff there. And I'm going to go and comment some stuff out real quick so we can look at this piece by piece. So far, the whole thing was everything we did, we basically again set those up, and then we just in the main file, what it did was set up an object in using shape called shape1, and basically just prints out that this is shape1, oval called oval1, and it basically prints out the X and Y radius as well as the name oval1, and circle 1, which just prints out again the radius and then what it is, circle 1. And so far, basically right here with the basic print, what we do is again, we just basically are using the object and just saying use the exact function inside of it. Same way with the inheritance and polymorphism that we saw in W3 schools and Geeks for Geeks. Basically, again, setting it up like this, it should be able to tell which function and class we're calling and use that exact one. So I'll go ahead and run it. Yeah, right here, basic print. So far for shape draw called. And again, in basic shape, it says drawing shape 1. That's the only thing it does. It'll just print out whatever it's drawing, and that's it. Then for the second one in oval, again, drawing oval 1, which is the description of it. And then it prints out the X radius and the Y radius. Again, since we put them in there right here. And that's the whole thing we want to hear too. Print out the X radius and the Y radius and everything stuff here, as well as the description. And then in circle, same thing, prints out a description and then prints out what the radius is. So again, description and the radius. So basically, again, that's how the basic part of it worked. That's like basic polymorphism and everything right there. So far, the other thing it showed was, because the entire video and everything and stuff here, it uses references and pointers. So in the free code camp video, they just use references and pointers the entire time. So basically just showing if you just kind of set up a pointer and everything like this, here's what result you would get. So saying if you're using pointers and everything, the only thing we're getting is just it's drawing the shape 1, oval 1, and circle 1. It's not giving us the other information like the basic print did, because so far with the pointer we have set up here, it's just looking at shape and that's it. It's just looking at this pointer and everything right here and just going, okay, so only use the functions inside of that and that's it. And basically saying if we kind of did it like this, we have to set up like multiple pointers and stuff and keep saying like use this, use this, use that. Just it's saying if we had like a bunch more shapes, like we had like 100, we have to set up a bunch of pointers. The point of polymorphism is we should be able to set up one thing and then just keep reusing it, and it should give us different information. So basically saying if you set up a pointer like this, it won't work. It will just look at this basic pointer here and just only use that, which is a problem. We don't want that. And then down here it shows with a reference that if we try doing it down here with a reference, the same thing should happen as well. Again, we're only just getting the basic shape class and that's it. We're only getting that function called and that's all. Because again, we're only using a reference of shape and that's really it. So with that, that's why it's not working whatsoever. That's like the whole promise of there. So we're just showing if we use static binding, basically we'll have a problem because this works, the basic print. But if we have like, again, 100 objects, we'll have to make a bunch of objects and then each one called draw, and we have a bunch of classes as well. So it's saying that's not really what would be a best thing stuff about this as well. So far the next thing, and I'll go ahead and bring that up right now. Yeah, the next thing talked about is polymorphism, dynamic binding with virtual function. Basically, again, this is when it actually starts getting into polymorphism and everything here. Again, with this, is basically just going to be using a bunch of references and pointers. So far, the main thing is this. I'll go in, like the main function, I'll go ahead and like scroll down here so you can just see all of this. Basically, it's a lot of the same stuff from before. The only main difference is that we just have a few extra things added, such as the functions and everything at the very top. Those are like the main things added and everything as well. So again, just go back up top, make sure, people can copy it. And so far, the only thing we added was just this word virtual right here in front of the functions inside of each header file. So again, in shape.h, we added virtual, oval.h, we added virtual, and in circle.h, we added virtual. That's the only thing we added. So basically with this and everything as well, what it's showing is, again, if we add in, let me comment some stuff out and everything too, because there's kind of a lot of stuff and everything here as well. I'll go ahead and just comment everything out and stuff as before, and we can just like start from scratch and everything again like we did last time. Whoop, wrong way. There we go. And you know what, why not? We'll go ahead and comment these out and stuff as well too. Okay, here we go. So basically, again, what this is right here is, again, the objects and everything. So shape, oval, and circle, making shape 1, oval 1, and circle 1. Again, if we print out basic, we get all the information we want. Drawing shape. For oval, again, drawing the shape and then the X and Y radius. And for circle, again, we get the radius and the name of it. So far, again, and I'll just go into the rest of them real quick for the other one. So far, with this is before, with pointers and everything and stuff here, before it would just only look at this pointer right here in shape and just only print out the name and that's it. We wouldn't get the other information that's like right here for oval or for circle. But since we added the word virtual in front of every function here, it makes it so we can use polymorphism. So now if we run it, you see that we now get every single thing that we wanted. So again, for shape, we get just a drawing name. For oval, we get the X and Y radius and the name. And for circle, we get the name and the radius. Basically, by adding the word virtual and everything in the front of it, it allows us to be able to reuse everything. So we basically can just like reuse a bunch of code and everything as well. So again, like we can set up the pointer and it knows, okay, the pointer is currently pointing at oval, which is using this class up here, oval. So it knows to look inside that class and use that function. Same thing with shape right here. The shape pointer, everything, it knows using circle 1, and that's pointing at, the circle class and everything here. So it knows to use that function and everything. Again, all this is because we just added the word virtual in front of the function of every one of them. And the fact that it's also public as well. And it also works for references and everything and stuff too. So I'm going to run this. Yeah, so dynamic binding with references, again, also works as well. We get the information, everything that we wanted. Again, basically, literally just the same code we showed earlier. Just again, because we added virtual in front of it, it knows now to look at each object that was made, see what class it's affiliated to, and then use whatever references inside that class. So that's the whole thing with polymorphism and everything there. Another thing the video did as well, would just kind of show that we can do other things, is basically it made 2 functions. So far, it added a function that makes it take a pointer and prints out the information, and one that takes a reference and prints out the information as well. So that will be these 2 down here. And let me comment the stuff from above out so we don't get like 100% confused on all this. So this and everything too, using basic function that takes pointers, basic one that takes references and everything as well. And this one, I'll comment this out too, so we won't like look at that in a second after. So yeah, basically we're looking at these 2 and everything. These 2 right here basically works on the functions that are at the very top, that are just inside the main file. Again, just takes in, this one up here takes in a pointer, prints out the information. This one down here takes in a reference and print out the information. So we're going to run it. And let me extend this so we can see it. So again, with this, same thing, get the drawing, the shape for shape, name of the shape and the X and Y radius, and the name of the shape and just the radius for the circle. Same thing with the references, we get the exact same information. Basically, this is showing that, again, with polymorphism, we can make a function and just, again, use short, like, things of code like this to get the information we want. Instead of having to make a bunch of pointers and classes and everything as well, we can just make this way more simple and everything. That's like the benefit of polymorphism. So if we had like 100 of these, we could make it easier to print it out rather than having to create a bunch of pointers and references for each and every one of them. Another thing as well that's also beneficial to this is that we can also just basically make a for loop and everything as well, make a collection. So let me comment this other stuff out real quick. Basically, again, just saying like we can make a collection using polymorphism, and it makes it way easier to allow us to just like print out a bunch of information without having to, again, make a bunch of extra stuff. So for this, it's a pointer, shape, the shape collection, and it contains, again, shape 1, oval 1, and circle 1. And for this, again, it will just print out everything inside of the, basically, pointer array and everything. So we're going to run this. And again, right here, we're getting all the information that we want. It makes it really easy. So if we had like 100 of these, we could just like keep adding on to this and then print it all out without having to have everything be separate. Basically, that's like the whole benefit of using polymorphism as well. Just again, basically just inheritance and using the word virtual. That's the main thing with that. And then just basically using pointers and references to do this. The main thing it did say though was that with this collection, you do have to use a pointer, because instead of use a reference, it won't work. It will just crash. Again, I don't have an example of that because again, it was a bunch of stuff, but basically again, it just says you have to use a pointer for this. That was the main thing. So far, the next thing the video covered as well, so far I'm just going through a bunch of this stuff, is basically just the size of using polymorphism. So far, again, the only thing changed is just this, the main CPP file. Everything else is the same, what we just had before. So it has virtual in front of everything. So far with this, I will go ahead and just comment this stuff out real quick so we can just see something. So far with this right here, it's just saying the size in bytes of using polymorphism. So we're just going to see the size of shape, oval, and circle, the classes. So we're going to just run this. And right here, you can see the size of shape is 24, size of oval is 40, and the size of circle is 40. Again, in my notes, I have here that the sizes were different compared to the video, because again, I'm getting 24, 40, and 40, but in the video, we're getting 40, 56, and 56. Again, I think it's just because of the compiler I'm using. Most likely that's probably what it is, but basically, again, it's just showing that, like, again, using a decent amount of bytes and everything too if you use polymorphism. And basically, if we just do this real quick, if we just basically delete the word virtual and everything as well, so I'll just get rid of these in each one of the header files, just get rid of virtual. We completely get rid of that, and just because I'll just do this as well, I will just go ahead and comment like this and everything and stuff as well. Literally, this is the exact same code as above. It's just, again, just my notes on the side are different, and that's really it. But yeah, so if we get rid of the word virtual, we'll see what it looks like using basically just static binding and everything as well. So I can just run it. And again, here you can see we have like completely different sizes. So again, shape with dynamic binding was 24 bytes. Without dynamic binding or polymorphism is 16. So basically, we can see like with each one, when we use polymorphism or put the word virtual, it uses up more space compared to if we don't use it. Again, basically, that's like the trade-off. Polymorphism is really useful, but it does take up more space. That's the main thing I just wanted to show. And so, again, I'll just say it one more time. Just like basically, again, just with using polymorphism, it'll take up more space than it would if you're using static size or, everything like that. I said also just go back and put the word virtual and everything and stuff here too and all. So again, in all the header files, just put virtual in front of it again. So I can just run it again. We just make sure the size changed. Yeah, it did 24, 40, and 40 like it did up here. And so far, another thing the video did talk about as well was, let me do this too. So far, the other thing it talked about was slicing. And basically what slicing, as it was saying, is basically if you don't use a reference or pointer with polymorphism, it will basically just slice off the child classes and only use the base parent class, and that's it. So with this, we have an object called circle1, and it's using the circle class. And again, right here we have shape equals circle1. So again, an object called shape that's using shape and taking the information from circle1. And then we use shape draw. So if we run it, again, the only thing it's doing is just printing out circle, and that's it. It's just saying drawing circle1. It's not printing out the actual information that would be in circle1. Because basically, again, like with using the circle class, it will be printing out the radius and the name of it. So far in shape, it just only prints out the name. And it's because of the fact that we're just using like basic static binding. That's why it's not really working. So we do have to use a reference or pointer with it. That is kind of like the slightly confusing thing with it. Because again, earlier we kind of showed you don't really necessarily have to. But if you kind of do it this way right here, you just have to type a lot of stuff. You can't really reuse a bunch of code. So basically, again, using references and pointers allows us to reuse polymorphism in a more like convenient way. So if we have like a lot of objects, we can just easily print everything out rather than having to make a bunch of things and then having to print each one at a time. So that's like the main difference between just using basic polymorphism, using static binding and everything as well. So, or basic difference of polymorphism slash dynamic binding versus static binding, which just, again, not using a reference or a pointer. And so far, this is the last thing that it talked about with polymorphism for now. Is basically polymorphic objects stored in collections. Basically, that was what I showed earlier, just like, again, putting things in a collection using pointers and being able to print out a bunch of information. Again, the only thing I changed here was just the main CPP file. Everything else is the same. All of them set virtual in front of it. Again, I'll just slowly scroll down. So again, just like pause and just, type out whatever you need to type and things like that. And so far, that's really it. Again, like I said, for and everything else that's virtual. We changed nothing else from the first one. So that's really the only thing. And so far with this, it's just showing that again, basically again for a thing we're gonna be using later, smart pointers, we need to include memory. But basically right here, just like we made a bunch of objects. So a circle, oval, just a bunch of these. And basically what we did is the video basically showed this. It showed if you use raw objects in a data collection and everything and stuff as well, it would just slice stuff off and only use the parent class and that's it. So far, I probably should just show this and everything too. So let me just. Yeah, so I just show this and everything too. So again, outside the circle, basically get the size of it and everything as well. And from here, again, we have shape 1, an array of that. And it basically has the circle and ovals. And basically says this will slice, so we'll only really just bring in the shape. So it's just only print out the name and that's it. So basically again, shape and everything. Like basically this will just run through the array and print everything out as well as print what the size of it is. So we'll just run it. Go ahead and do this. So basically with this and everything too, it did that. Like again, outside of it, outside of it, circle 1 is like 40. And then the size of each object inside of the array is 24. So again, using a collection takes up a little bit less space on its own. But again, as you can see, with each one, it only just prints out the name circle 1, oval 1, rather than printing out the X and Y radius like it's supposed to. So again, if we have it just as like this and everything too, just store it as raw objects and data, it will slice and only just use the parent class. It won't use the child classes whatsoever. So that's the whole problem and everything and stuff there. So I'm going to comment this stuff back out. So far right here, if we use just straight up raw references, so we just straight up like storing references and everything here too as well. So again, pointer, and we're storing in references and everything as well. The problem is, again, it will just crash. Or granted, sorry, I messed up entirely. So far again, just okay. I was looking at my wrong notes and everything. All right. Up here is basically saying again, if we just use straight up references, it will crash. It won't work. So basically, if we just use this, we will get an error. So again, I probably should just use it just in case, just kind of see. So we'll just run it. And again, we get an error at line 40 right here saying declaration is shape 2 as an array of references. So this won't work. And so far right here, we use raw pointers and everything like that, which is the way it's supposed to be. If we use pointers, so again, pointer and everything here inside of it, again, dereferencing them. And again, we have a for loop to print all of it out. So again, same thing. We have the size of it outside the loop and the size inside the loop. So we'll run it. And again, outside the loop, it's 40, inside is 24. But as you can see, with us using pointers, it prints out what needs to be done. So a circle is printing out the radius and the name for each circle. And then for the oval, it's printing out the name and the X and Y radius. So you can see using raw pointers and everything, this does work. And so far, the other thing that it used as well, let me go ahead and comment this back out so we can see. Whoop, I messed that up. So far right here, basically it introduced something called smart pointers, in which, again, the video, I'm just going to call it out here. So far, he just used this. I don't remember if he ever showed us this. I'm pretty sure he didn't. But he just kind of used this and that's it. Like, this is the most explanation we're going to get on what this is. So I have to look this up on my own and figure it out. But basically, again, to use smart pointers, remember we have to include memory. That's the main thing we have to include for this. But yeah, basically again, using smart pointers and everything as well. So from this is make a circle, and then we have the information here, make an oval, the information as well, and then we have it printed out. 100% how this works, I don't know, because again, he really never told us anything about it, but still. So basically this whole thing here just is circle draw called, drawing circle 4 with radius, and then over here drawing oval with the radius and everything as well. So that's the whole thing and stuff there too. Again, just something he showed, didn't really explain that well, but yeah, that was really the whole thing and stuff here. And that was everything with polymorphism currently that I saw with the video. Again, this was a lot of stuff, and like I said, it's just that like majority of it just basically related to inheritance and using pointers and references. Again, this video is the only thing I could find really talking about polymorphism with references and pointers. Everything else would just kind of just talk about it like basic inheritance, and that's it. So again, this is a thing where you might have to look at the video and just kind of go off this guy's word here. I don't know what to look up to find any more information on it, so I have no idea. But yeah, so far that was really it and stuff for this. Just again, a bunch of polymorphism, and yeah, that was really all. So to myself and everybody else, see you in the next one.